Good morning, all of you. Myself, Prashant Patil. Today we will see here unit number 3, stack and queue. First, we will see here introduction of stack. Consider that we are having one such type of array which is having some properties to follow while storing and retrieving the element. As you know that array having some properties, we can insert the element in the array at any position. Also, we can retrieve the element from array from any position. Suppose whenever we want to insert the element, it should be stored at the index 0, then index 1, then index 2, and so on. Element of the last index should be retrieved first. These are the some properties of an array, so which is called as a stack. In array, elements can be inserted and deleted from one position, but in stack by using the array, elements can be inserted and deleted one end. This end is called as a top end. Now here we will see stack as an ADT, means what? Abstract data type. A stack is a linear data structure which follows the LIFO principle or LIFO structure. The stack has one end. By using this end, we can insert the element and we can retrieve the element from the stack. It contains only one pointer. The pointer name is that top pointer, pointing to the topmost element of the stack. The top is a pointer, always point to the topmost index of the stack. Whenever an element is added in the stack, it is added on the top of the stack and the element can be deleted only from the top of the stack. In other words, a stack can be defined as a container in which insertion and deletion can be done from one end. This end is called as the top end of the stack. Now here some examples of the stack. The first example is that stack of coins. Here coins are placed one above other. Then stack of plates. Here plates are placed one above other. Can of the tennis ball also here placed one above other. And stack of books. Here books are placed one above other. These are some examples of the stack. Now here we can see that how to insert the element in the stack. Insertion means what? The elements are pushing inside the stack. We can insert the element in the stack from one end. This end is called as the top end. Here the first element is ready to push inside the stack. Before pushing inside the stack, first top is incremented by 1. Initially top is set to -1. Then here in the second diagram, here element 2 is ready to push inside the stack. Before pushing inside the stack, first top is incremented by 1 and then we can insert the element 2. Likewise, in the figure number 3, here element 3 is ready to push inside the stack. Before pushing inside the stack, first top is incremented by 1, means top is equal to top plus 1, and then we can insert the new element which is 3. The next diagram, here element 4 is ready to push inside the stack. Before pushing inside the stack, here also we can increment the top by 1, which is top is equal to top plus 1, and then we can insert the element 4. The next element is 5. Here 5 is ready to push inside the stack, and before inserting the 5, first top is incremented by 1. Now this in this situation stack is full. Here we can see that structure of stack. Type def struct stack. Here struct is the one keyword, stack is the name of the structure, and type def is the one keyword. By using the type definition, we can use here stack as a user defined data type. The members of the structure are integer data with size and int top and with semicolon, and then close the body of structure. And here we can create the structure type variable stack, and this stack is worked as a user defined data type. Now here we will see some operations of the stack. The first operation is that push operation. The steps to involved in the push operation is given below. Before inserting an element in the stack, we check whether the stack is full or not. When top is at max -1 position, then we can say that here stack is full. If we try to insert the element in the stack and the stack is full, then this situation is called as the stack is overflow condition. Whenever stack is full means our top is at max minus 1 position, and here we are forcefully performing the push operation, then situation is called as stack is overflow. When we initialize the stack, we set the value top as a -1 to check that the stack is empty. Whenever we are setting the value of top which is -1, then it indicates that here stack is empty. When the new element is pushed in a stack, the first value of the top gets incremented, which is top is equal to top plus 1. Initially top is -1, top is equal to top plus 1 means what? -1 plus 1, which is 0, means what? Top pointer points to the location number 0, and then we can insert the element at the location number 0. The element will be inserted until we reach the max size of the stack. Here we can insert the element one by one until the max size reach at the top is reached at the max size minus 1 position. Now here we can see that the first diagram, this is an empty stack. Why? Because here top is set to -1. Here 10 is ready to push inside the stack. Before pushing inside the stack, here first top is incremented by 1, means our top is equal to top plus 1, and here initially top is -1 plus 1, which is 0, top is pointed to location 0, and then we can insert the element 10. Likewise here we can insert the element 20, 30, 40. Okay, after inserting the element 40, again we are performing the push operation, means what? Here we are performing the insertion operation, but here top is at max -1 position, so this stack shows that here stack is full. Now here we can see that a function definition of push. Word push. Push is the name of the function and word is a return type. In bracket int volume, int value, comma int max. These are the two parameters. Inside the body of function definition, if top is equal to max -1 position, then it returns overflow. Then it shows the stack is overflow. Means what? Here top sets, if suppose top reach at max -1 position and if condition is true, then it shows the message stack is overflow. If suppose top is at -1 position, top is at 0th position, top is at 1 position, and so on, then this condition is false, and then enter inside the else. Then top is equal to top plus 1, means what? If suppose top is -1, -1 plus 1, top is reached at location 0, means what? Stack of top, stack is the name of the array, stack of top, stack of 0. Here we are inserting a new element. The second operation is that pop operation. Pop operation means delete operation. The steps involved in the pop operation is given below. Before deleting the element from the stack, we check whether the stack is empty or not. If stack is empty and we are performing the pop operation, then this situation is called as stack is underflow. If we try to delete the element from the empty stack, then the underflow condition occurs. If the stack is not empty, we first access the element which is pointed by the top. Once the pop operation is performed, then top is decremented by 1, which is top is equal to top minus 1. At the time of deletion, at the time of pop operation, the topmost element is assigned to any temporary variable, for example x, and then here top is decremented by 1. At the time of insertion, we can increment the top by 1. At the performing the pop operation, we can decrement the top by 1. Now see here in the first diagram, stack is full. Why? Because here the stack contains 4 number of elements and top is at max -1 position. Here the topmost element is assigned to any temporary variable, for example x. Then here top is decremented by 1. Here top is at location 3 and here top is decremented by 1, so top is equal to top -1, so top reach at location number 2. Likewise at the time of performing at the time of deletion operation, at the time of pop operation, always top is decremented by 1, and finally in the final diagram or the last diagram, top is equal to -1, means out here stack is empty, and here we are forcefully performing the pop operation, then situation is called as the stack is underflow. This is a function of pop. Pop is the name of the user defined name of the function, and void is the return type. If top is equal to -1, then it returns underflow message. Otherwise else x is equal to stack of top, and here top is equal to top minus 1. If top is equal to -1, the -1 condition is that here stack is empty. If condition is true, then it returns the message underflow, stack is underflow. If top is at location 1, 2, 3 and so on, then if condition is false, then enter in the else. Then here stack of topmost element is assigned to a temporary variable x. Here stack is the name of the array, and top is a variable which points to the topmost element. Stack of top which is assigned to the variable x, and then here top is decremented by 1. If suppose top is at location 4 and location 4th element is assigned to a variable x, and afterwards top is decremented by 1. Here top is 4, 4 minus 1, 3, means top is pointed to location number 3. The third operation is that initialize void initialize in bracket stack pointer p. P is the pointer which is declared by using the stack, because here stack is worked as a user defined data type. Whenever we call this method, whenever call this function, p is the pointer pointed to top is equal to set to -1. The next function is that empty. Int empty, int is a return type and empty is the name of the function. As a parameter we are declaring here pointer p by using the stack. Here stack is worked as a user defined data type. If top is equal to -1, then it will return 1, otherwise return 0. If top is equal to -1 means what, here stack is empty. Whenever stack is empty, then it will return 1, otherwise if stack is not empty, then it will return 0. Then full. Int full is here name of the function is that full, and the return type is that integer. The parameter, here we are passing the parameter pointer p, and this pointer p is declared by using the stack. Here stack is worked as a user defined data type. If top is equal to max minus 1 means what, top reach at max minus 1 position, then it will return 1, otherwise return 0. Whenever it will return 1 means what, here stack is full, otherwise it will return 0 means what, stack is not full. Thank you.